Welcome to the weekly challenge videos. If you like this kind of content, please like or subscribe. And if you'd like to see even more of these challenge questions, I have a lot more on my courses website, link in the description below. So let's look at a contestant in a winter sporting event pushes a 45 kilogram block across ice across a frozen lake. As shown below, the coefficient of static friction on shoes on ice is 0.3 and the coefficient of kinetic friction is 0.1. Calculate the minimum force you must exert to get the block moving. Okay. So now we just have to, so basically with static friction, whether you have to decide if you're doing static or kinetic friction, but in order to get started moving, I have to overcome static friction, right? So when I draw my free body diagram of the block of ice, I have the mg down, I have a normal force up, and then I have a force downward from, his applied force. And then I'm going to have a frictional force moving to the left because it's going to oppose my motion, right? Static friction is going to oppose him from moving. So it's going to move to the left, which is parallel to the surface, right? So friction is always parallel to the surface. Okay, now it's a static friction. All right, so this is static friction in this case because I need the minimum force I need. I need to overcome static friction. I need to overcome the maximum static friction before it starts to move. Okay, so now we have to decompose our forces in the horizontal and vertical direction. This is going to be F cosine 25 degrees, and this is F sine 25 degrees. Right? That's how it breaks down into my little right triangle there. Okay, and then we want the acceleration to be 0 because it's just starting to move. It's just starting to accelerate, so it's barely accelerating, right? So the minimum force is right on that hairy edge where you just get it to start moving. So the acceleration is still 0. All right, so let's look at the net force in the horizontal direction. It is going to be, let's say right is positive and up is positive. So to the right, we're going to say F cosine 25 degrees minus force of friction. Those are the two forces in the horizontal direction. That equals 0. All right, in the y direction, we're going to say the net force. I have normal force upward, and I have two forces downward. I have mg and f sine theta. Or sine 25 degrees. That also equals 0. Okay. Now, force of friction. So these are the equations that I'm relating. The last one is the force of friction equals the maximum static friction. That equals mu s times the normal force. Okay? So this first equation is really F cosine 25 degrees minus mu s Fn equals 0. But I can solve for what Fn is, right? Fn is this. From here I can find Fn is equal to mg plus f sine 25 degrees. So I can plug that into there, right? So I have F cosine 25 degrees minus mu s times each of these, mg plus f sine 25 degrees equals 0. Okay. I'm going to do this also. So I'm going to distribute the mu s, right? So F cosine 25 degrees minus mu s mg minus mu s f sine 25 degrees equals 0. I'm solving for f, right? So I need to keep everything with f on one side and move that to the other side. And here I'm going to factor out an f. So it's going to be F cosine 25 degrees. See, out of these two terms, I'm going to factor out f minus mu s sine 25 degrees. And this guy gets moved to the other side. So I have f is equal to mu s mg over cosine 25 degrees. Yeah, last thing is I got to divide this term to the other side. And that's how I solve for that. Okay, so we're using static friction, right? So it's 0.3. What was the mass of the block? 45 kilograms. Here I'm going to do cosine of 25 degrees, which is a calculator thing, minus mu s, which is 0.3 times sine of 25 degrees. And I get 169.7 newtons. All right, so that handles that one. Now, once it starts moving, if I use the same force, what is its acceleration? That's right. What is its acceleration once it starts to move? So once it starts to move, now it's kinetic friction. And now definitely we still are going to have the same free body diagram, but this force of friction is now going to be kinetic friction. And the other thing is we know what F is. So if we just look at our equations again, in the horizontal direction, the net force is F cosine 25 degrees minus the force of friction. Now this is accelerating in the horizontal direction. There's a horizontal acceleration. It's not zero acceleration anymore. And in the y direction, it's still the same. The y direction acceleration is zero because it's not accelerating vertically. There's no vertical component of acceleration. So this is Fn. So we use the exact same equation. Minus mg minus f sine 25 degrees equals 0. Okay, so we can solve for the normal force again. And then plug that into there. And we get F cosine 25 degrees minus, this force of friction is now is mu k times the normal force, right? Because it's kinetic friction. So minus mu k times mg plus F sine 25 degrees. I'm not going to simplify this too much because all I have to do now to get rid of the m on this to solve for the acceleration is divide by m. So I'm just going to plug in all the numbers. 169.7 cosine 25 degrees minus 0.1 times 45 times 9.8 plus 169.7 sine of 25 degrees. All of that divided by 45 kilograms. I get 2.28 meters per second squared.